This first video, I just want to look at some of the built-in functions that Excel has and some of the pattern recognition. So the first one we're going to be looking at will be patterns. This one seems really simple, and it is, and luckily this will not be the larger hurdle that you will face in this class, but it can make life a little easier. So for example, if we are going to do multiple trials of an experiment, you can write out, trial 1, 2, all the way down to however many we have. But if we have like 10, it won't take that long to write. But if you just write, let's say, I write 1, 2, and if I just highlight them, and this little green square in the bottom right-hand corner of the highlighted section, if I hover my cursor over it until it becomes a black plus, I can click and drag, and we can see the numbers counting right next to it, and it will just continue that pattern. You'll probably end up using that a few times. It's not a huge hurdle, but sometimes it makes life a lot easier. Also, Excel is pretty good at recognizing certain patterns. For example, if I want to just type a bunch of even numbers, I can type 2, 4, 6, and 3 cells is usually enough for Excel to know what pattern you're going for. So if I continue this down, I can see 8, 10, 12, 14, all the way down to 20. But, and this will be a theme throughout the class whenever you use Excel, Excel is not always as smart as we want it to be. For example, if I tried to do a pattern where it doubles each time, 1, 2, 4, 8, Excel has no idea what to do with this, and we'll get some weird unexpected behavior. So if you ever get weird unexpected behavior when you're trying to do something in Excel, just know that it's because Excel's trying to be smart, but it doesn't always work. I'm not even sure what it's trying to do here. But on to more important and pressing matters. Here are some things that you'll actually use quite a bit in this class. Every single lab should use some form of this. So what I've set up here is just some fake data table. This all means nothing, but the idea is if each trial is some different setup, so let's say, trial 1, I've arranged my experiment a certain way, and then trial 2, I've changed the arrangement to some other thing. So they should all have different numbers. But for each one, I've taken 3 measurements. And this will be pretty common in a lot of our labs. We will have the same setup, but we will time it 3 times to get a good idea of what's going on. And then we'll change it to this setup and time that 3 times, so on and so forth. And we want to know, okay, so for the first type of setup, each time my measurement was slightly different, and that just happens because of some random errors or measurement uncertainties. This is just why we take multiple measurements. We want to get a good idea from the average. So of course you can just take out your calculator and do trial 1's number plus trial 2's number plus trial 3's number and divide it by 3. And that will work perfectly well. And you can just type it into the cell and take the standard deviation and then do it for the next one. And with only 10 rows, you could do this. It would take you a few minutes, but it's not horrible. But 1, there's a much easier way to do it, and 2, once we start getting multiple rows of data, like dozens to 100, you will not want to use your calculator and type it in. And I'll talk about a few other benefits. But if you are not already familiar with some of Excel's built-in functions, let's look at them. So average, if I hit the equal sign, it will tell Excel that I'm about to start typing some equation of some sort. And luckily, Excel has a plethora of built-in functions, so if I just start typing average, we can see average. So I can either finish typing it, I can click average, and if my computer would not freeze, well. So what I like to do is when I see that it's what I want, see average is highlighted, I just hit the tab key and it completes. And now there are 2 ways to do this. My favorite is to just click and drag, and it's, close up the parentheses and hit enter. So now it's just taken the average of those 3 cells. And if I click up here in the box, it will show me the range I highlighted. That's a good thing to do if you're ever seeing weird behavior. For example, if I had accidentally highlighted these three, I wouldn't see it here, but I could click up here and say, oh, I made a mistake. These are the three I want. Great. Now, another thing you can do, because sometimes the numbers you want aren't all in a row. So if I hold down the Control key and click the three cells that I want, it will still do the same thing. So I prefer just when I can, if they're all in a row, there's no reason to Control click everything, so I'll just do that. And good. Now I want the standard deviation. Again, you can just start typing in std, and we see all these stdev dot somethings. This one's a little weird because there are so many different standard deviations. This one, I believe, is the old one that it would use. This one here, stdev.p, is for a population standard deviation. We are often working with samples, stdev.s, because we're just taking a sample of data. So this will be the one that we want, stdev.s. And again, do the same thing where we highlight and hit enter, and we're good. Now here is another fun function, or another fun ability in Excel. Of course, you could just do the same thing for all of them, type the average, highlight, hit there, stdev.s, tab, highlight what you want, hit enter. But once we get a lot of rows, this is kind of cumbersome. So here's something I'm going to do. I'm going to get rid of these. So this one, if I click and highlight, I see it's using the first row, but now I want to do the same thing on the second row. Remember how I clicked and dragged on the last screen? I can do the same thing here, and if I click in this cell to actually look at what it's doing, I notice that as I dragged this equation down, it also dragged its reference down. So it knows that when I used this one, I used a certain set of rows, so if I drag the formula down by one, it's going to drag all of the rows, or all of the cells that it uses down by one, which is great, because now I can just drag this all the way down, and it will apply the formula one row down for each one. Now I can do the same thing here, but a nice quick little trick, if I know that it's just going to fill down to the end of the rows I have, I can just double click this little green box on the right corner, and it will autofill down to the end of the data. And if I want to get the average, or the sum, let's say, of this entire column, I can just type in sum. Basically, if it's a common math feature, Excel probably has it as a built-in function. And notice that it uses that entire column, and again, I can drag to the right just the same way that I dragged down. So now I'm using the next column over, and the next column over, and we're great. One more quick feature before I end. Let's say I accidentally start typing something in and I want to get out. If I just hit enter, it's stuck there and it doesn't know what I just did. So if I accidentally start doing that, you can of course just backspace, but if you hit the escape key, it just pretends you didn't do anything, so it's stuck on that last one I finished. So if I do this, hit escape, it just gets rid of it. That's handy in case you accidentally type over. Like if I just hit 4, if I backspace, it will erase what I had there initially, but if I hit escape, it just says, forget everything I accidentally typed, keep what was in there before. All right, so here I've set up an example data table. So up here I've just written maybe some one-time measurements. Let's say I have a mass that's 2 kilograms and I'm putting it on some accelerating track or having a motor accelerate at a constant acceleration of 3 meters per second squared. I'm going to take measurements at times 0, so initially before or just as things are about to start going, and then at 1 second intervals up until 10 seconds. I know the equation for velocity is the initial velocity plus the acceleration times the time, and the equation for kinetic energy is just 1/2 times the mass times the velocity squared. So this is a fairly simple experiment, but let's just look at how we would build in our equations. So unfortunately for us, Excel does not have a built-in velocity function or a built-in kinetic energy function, so we're going to just write our own equations. Again, we could just pull out our calculators and type it into each cell, but for an experiment like this, we would probably have a digital measuring tool that would take 100 or 200 data points, and we would have to calculate and plot, and I'm not going to pull my calculator out for that many data points. So let's build our own equations. First, initial velocity, I'm going to say 0. It's going to start from rest. So now, let's look at our initial kinetic energy. There are two things I can do. I can just write 0, because I know right away times 0 squared is 0. But I'm going to jump right into making our equation. So, just like how I used Excel's built-in functions, I'm going to start by typing an equals sign, and now I'm going to start typing my equation. So, parentheses 1 divided by 2 for the 1/2. In general, my advice on parentheses in Excel, more parentheses is often safer than fewer. Like we saw, Excel can be pretty smart, but it's not always as smart as we want, and I don't have complete confidence in how well it can do order of operations. So anyway, 1/2, and then the times is the asterisks above the 8. Excel does not let you just do 1/2 and then a number. You have to explicitly put in the multiplication sign. So 1/2 times the mass, which I've written here, and it's important when you're typing in Excel to separate the label from the value, otherwise Excel will get confused. So 1/2 times, I can click on the cell, times m, times v squared. I'm going to click now on the velocity cell and do the little caret 2 for squared. So that caret sign is raising to the power and then 2. And of course it comes out to be 0 because we have 0 velocity. Great. So let's do the same thing with our velocity. We say our velocity is equal to the initial velocity, which is just 0, plus the acceleration times the time, which is we are at the 1-time timestamp. Boom. And just like how I saw earlier, if I want to drag down formulas, I can do that perfectly well. Now there are going to be some issues, and let's look at what they are. So if I drag down this velocity equation, it looks like it works at first, although it doesn't change, so there might be an issue there, but then we get all these value errors. So remember, if we click inside this text box up here, it will show us the cells we're using. So it looks good, acceleration, initial velocity, and the time. Good. Hit escape, get out. Now if I go down to this next value and I click it, look, all of the boxes have shifted down, which normally is a great thing, and we will make use of that feature. But notice that the acceleration should be, every point should be using the same acceleration, and every point should be using the initial velocity. So here, I want my acceleration to stay anchored on this point, and I want my velocity point to be anchored on 0, since it's the initial velocity. There will be some functions where you have to use the previous velocity, so this one would be fine. But for our purposes, we want everything to stay except for the time. We want the timestamp to move. And that, of course, is what the issue is here. It's trying to use this label, and it's just getting messed up. Okay, so let us fix our equation. So notice B5 is written in blue, and this box is in blue. We know that this is our initial velocity. We want to do what's called anchoring that. So if I put a $sign before the letter and before the number of the cell, that will tell Excel that I want that reference to stay where it is and not shift when I pull the equation down. Now I want to do the same thing with acceleration. I'm going to anchor B2. And then this A6 is our time, but we do want that to move as our equation pulls down. So now let's hit enter. Of course, our first value has not changed, and I'm going to just drag this down. Perfect. So we can see that our acceleration, or our velocity, is gaining 3 meters per second every second. Perfect. But now, before I pull down the kinetic energy, we let's look back in it and make sure everything is as it should be. So again, this velocity, I will want that to come down with us because it's 1/2 times the mass times the current velocity squared. So this velocity does not need to be anchored. But good thing we checked because this mass I want to stay where it is. So I'm going to put the $sign before the letter and the number of the cell, and we're good. So I'm going to click on it. I'm just going to double click this little box and it drags it down, and I can check and make sure mass and velocity are being pulled from the right spots. Here we're going to be looking at plotting in Excel, which is another feature that we will use almost every lab, if not every lab. So using the example from our equations video, I have just added another row here, and you'll see why, just to demonstrate 2 data series on one table. And so I've added a second object. It's not important, it's just to give us extra stuff to plot. Okay, so first off, doing a plot in Excel, this Insert tab up here at the top, whenever you want to put something in or insert it, you'll click on Insert, and pretty much everything you want is here. The scatter plot this should be the only type of plot other than a histogram that you use in this class. So you will use scatter plots to plot your data, and occasionally you'll use a histogram. Generally do not use these line charts. They're not that helpful. Just connecting one data point to the next isn't super useful in physics because we are often taking data from a noisy experiment, which means we just want the scatter plot and then to put a best fit line to it. So again, if I just highlight the data I want and click Insert Scatter Plot, Excel's usually smart enough to know what I'm saying. And look, perfect. It labeled it for us correctly, and it puts our data here. And we can see time on the x-axis, looks like all the points match up, and velocity on the y, looks like everything matches up. Now, it works if you just highlight and then insert. I am not a huge fan of that method just because we saw it worked perfectly fine, but sometimes Excel thinks it's being smart and it gives us a really bad plot. So if you're ever wondering why your plot is doing something weird, if you highlighted and then inserted, that might be the reason. I've seen issues where including this title column or this title row has messed up the plotting for some reason, and I could not explain to you why. So I prefer to just insert an empty scatter plot, and we see it's blank, but if I right click it, I get select data as an option. So I'm going to click that and add. Okay, so here, series name. When I'm just plotting a single thing, I don't generally use this. We will see in a second when I plot 2 data series on a single plot, I will fill this out because this will be what is used for the legend if you include one, which you always should, if you have more than one data series. If I only have one data series, this name will just by default be the chart title. But I'm just going to leave it blank because I'm only going to plot velocity right now. Series X values. I can just start typing in here, or I can click this, and I know my X is going to be time. Good. I hit enter. Then I go here and click this arrow to fill out my Y values, and I'm going to plot velocity on the Y. Good. And now we see the same chart we had before, except it isn't labeled. So now I can, change my chart title. If you double click things, it will pull up this menu on the right hand side, which is actually very useful, and it has a lot of features that you will often want to find, which is great. Now we will also want axis labels. So if I go to this little plus on the top right of the chart, it will let me add things. So I'm going to do axis titles, data labels. No, I don't want that. Error bars we'll look at in just a little bit. Legend, when it's only a single data series, you won't need this. Trendline, we'll use trendline a lot. So I could just click plus, or the checkbox, but if I go to this little arrow here and more options, it will change this right bar, and I can do linear, polynomial, whatever. Generally, we're going to use linear in this class. And then I can click Display Equation on Chart so I can see what's going on. Of course, this is a very simple equation. We're just doing 3 times the x value, which is time. Great. And then I can change these labels to whatever I want. Always make sure you include your units on the different axes. Awesome. So that was a lot, but luckily this is a video. You can rewind and watch again if I'm talking quickly. But let's do what I said earlier and include error bars. So here, let me insert a column. I'm going to call this dV in meters per second. dV stands for the uncertainty in V, just D for the little delta sign. Don't worry about that. You'll see it in the manual. Now, I'm just going to make these up. Let's say I've got an uncertainty of 0.1 for the first one, 0.1 again maybe. Let's say I've got 0.2, 0.3, 0.1 again. It doesn't matter. These will usually be your standard deviations, but here I just need numbers for the plot. Great, okay. So if I go here again, and let me do my axis title so you can see. Time, seconds. Velocity in meters per second. Oh, and this is a subtle but important point that took me forever to figure out. Velocity, oops, if I can spell, versus time. Okay, so you'll often see plot quantity A versus quantity B. When it says A versus B, it means the first thing A on the y-axis versus the second thing B on the x-axis. It won't change the physics of what you're doing, but it will change, it will make a difference if you're trying to interpret it logically speaking. For example, it's the velocity that changes with respect to time and not time that changes with respect to velocity. Okay, now we have that out of the way. I'm going to go back to this plus, add a chart element, go to error bars and click plus. Okay, so normally I would hit this little arrow to go to the extra options, but I'm just going to click out so we can see what to do. So these, it just threw on some random error bar that means nothing. So if I double click the error bar, it will change this right window. And good, the cap is on it, perfect. We are on the horizontal error bar, great. Now, right now, it's just doing a standard error. I could give it a fixed value, a percentage, standard deviation, but mostly we are going to do custom. This will be kind of our thing. Now, oh, and while I'm doing this, actually, let's add an uncertainty for the time. dt in seconds. I don't like that that's capital. Okay, now I'm just going to say it's always 0.05. Let's just always make it that. And now that I've done the same one twice, it will fill just the same value. Okay, let's go back to these horizontal error bars. So you could just do a fixed value of 0.05, and that would work perfectly well. And we can't really see them, but oh. And now I'm on the vertical error bar, but if I want to go back to horizontal, I'm going to click error bar options, so this error bar options here, and go to series 1 X error bars. Good, so I'm back here. Even though they're all the same, which is perfectly fine, I still just like to do custom because it means if I made a mistake and have to change something later, I won't have to go back in and change the error bars. Great. So we have a field for positive error value and negative error value. For us, the positive error and the negative error will be the exact same. We will just have errors that say plus or minus this amount. So while I'm in that positive error value, I'm just going to highlight my dt column. And then the negative error value, I'm going to get rid of this set 1. I'm also going to highlight the dt column, which is great because now I know that I'm plus or minus 0.05. And it does the same thing as if I had set a constant error. Now you'll see that the error bars are now too small to see. That's fine. If this ever happens, just make sure you write in your lab report that you do have the error bars, but they're just too small to see. and then I can check your table and say, oh, you're right, it's 0.05, we're not going to see that on this scale. But now let's do the Y error bars, because we should be able to see these. And again, like I said, if you're ever able to click one of them, or let's just go here, chart options. Yeah, so if I can click anything, maybe you can't click the error bar, you can't see it, but you can click the chart, and you have this bar on the right-hand side. Go to where it says chart options and click this arrow, and go down to Series 1 X error bars. We did that, but we want Series 1 Y error bars. Good. Sometimes you won't be able to see it. If that's the case, the unplug it and plug it back in method kind of works here, but the equivalent in Excel is just delete the chart and make a new one. That will usually fix the issues. But anyway, error bar options, Series 1Y error bars, and this isn't the stuff I want, but if I look up here, I'm selected on the paint can. I want to be over on this histogram icon. So good both directions, cap, yes, custom, same exact thing, except now I'm going to choose this DV. Great. Click this and DV. Awesome. Great. And of course they're too small again. You know what? I'm going to change these just because. And let's say it's 5, 2, 5, 6, 2, 1, 1, 8, 2. Okay, and that's why I really like doing the custom error bars, because oftentimes I will make mistakes and I have to go back and change the data here. Luckily, none of this will change, which is great. And that's also one of the benefits of using our own built-in functions. Like if any of my values change, everything linked to it will change as well. So always, always, always use Excel's functions and equations, even if it's easy and you can just type it into your calculator, because then everything will update as you change data. Okay, awesome. So that's one plot. Great. Now let's look at doing two. And this is a great example where it's just a lot easier to insert a blank scatter plot. I'm going to move this down here because I don't care about it now, and select the data later. So I made two energy columns because it doesn't really make sense, but it doesn't make any sense to plot velocity, which has units of meters per second, on the same plot as kinetic energy, which has units of joules, on the same plot. So we're going to go back in, right-click, select data, add a data series. Here I am going to use the series name, and we'll see why. Kinetic energy 1. I'm going to select X values, which are just my times. Great. My Y values, which are all of these kinetic energies. Great. Add it. Now I want to add another one. I'm going to call this kinetic energy 2. Select series X values, the same time values. They don't have to be the same. Some will only be measured at some points, but often they're the same. Series Y values, this time same thing, but now the kinetic energy 2 column. Great. And now we can see, if I hit OK, that it didn't give an automatic chart title, which is great because it wouldn't know what to label it. But it has given me two data series. Now I don't know what these are, but if I go to the little plus icon, I'm going to do axis titles, chart title. We'll do error bars in a second. But legend. If I click legend, I can now see that it gives me the kinetic energy. Or it says kinetic energy 1 is the blue, kinetic energy 2 is orange. I'm going to increase this a little bit just so that I can see a little better. Let me label my axes. Time, seconds. Kinetic energy in joules. Great. And we'd probably label this like mass 1 or mass 2 instead of kinetic energy 1, kinetic energy 2, but you know. KE versus T, or a better label. Okay, so we're pretty much done here. Let me just add some fake uncertainties again. DKE1 in joules, DKE2 in joules, And I'm going to go here, add error bars. I'm just going to go to this arrow, more options. It will ask me which one I want. Kinetic energy 1. Let's go here. Again, it put me on this paint can icon. I want to go select the histogram, set custom, and I'm dealing with kinetic energy 1, horizontal axis, or the x-axis, which means I just want my time uncertainty again. Great, plus minus that. I'm going to go error bar options, series kinetic energy 1x, series kinetic energy 1y. Custom, specify, and even though I haven't filled in values yet, I'm just going to do this for the plus and minus error, and we see it went away, which is good for now. Now let's switch over to our kinetic energy 2. So I have the horizontal error bar selected. Again, this, you'll get some repetitive steps when you do your labs. You'll need to put a lot of the same error bars in. I'm going to go to kinetic energy 2y error bars, custom, specify, positive error value, DKE2. Hit tab, negative error value, it's highlighted, DKE2. Good. Now I'm just going to start throwing in numbers. And say I've got one with a lot of uncertainty. Look, it's the only one I can actually see. Again, these numbers aren't actually following anything. You will have real numbers when you do it, but just for the sake of this, let's give a really high one. That's a massive error bar. Let's say this experiment was just really hard, and for some reason we had really bad errors. Yeah, okay, great. So now we have error bars. So your plotting will be more or less the same procedure. You can plot plenty of things on the same plot. This little plus in the top right corner will give you a bunch of options. Let's look at adding a trend line. With 2, again, it will ask me which one I want to select. So kinetic energy 1. If I double click the trend line, it will bring me here. Again, go to this histogram icon, and I can change, and I chose something that it can't do for this one, which makes sense. But yeah, same idea when we're working with multiple data series, just you'll have more options. Okay, great. I think that is it for the plotting video. It was a little longer, but this will be a massive portion of what you are doing. I guess before I leave, let's look at interpreting the slope really quickly, just because this will be a huge part of your labs. So going back to the velocity versus time plot, if I look at this, and actually let's do this. I'm going to change my initial velocity. Let's say I started going 2.3 meters per second. So time 0, it was already moving. Notice everything updated. My slope stayed the same on the velocity versus time plot, but the y-intercept changed. So y velocity equals 3x time plus 2.3. So notice the x, or the y-intercept 2.3, has to have the same units as y, meters per second. And that is just telling us that is the y value, the velocity, at an x value of 0, so at time equals 0. So when time equals 0, y equals 2.3 meters per second. That is the initial velocity. So your y-intercept will often be interpreted as the initial value of whatever you're plotting on the y-axis. Now the 3x, let's look at that. X, of course, is just the variable for our x-axis, so for the time. This 3 is a slope. Now the slope is rise over run. In other words, it's whatever's on the y-axis divided by whatever's on the x-axis. So a velocity versus divided by a time, meters per second divided by seconds will give us units of meters per second squared, or meters per second per second. Now that's an acceleration. That's telling us how velocity is changing with time. So this 3 has units of meters per second squared, and if we go up, we notice, oh, that's our acceleration, 3 meters per second squared. So in this case, our slope is our acceleration, and you will often find that the slope of our best fit line will correspond to some physical quantity. So it is always worth it to take that slope and do a little unit analysis. So take the y-axis units, meters per second, divide by the x-axis units, in this case seconds, and find out what they equal and what physical quantities in our lab that will be measuring. Let's say I wanted to highlight all of these, like I wanted maybe to copy and paste, or if you highlight, you can drag over a row or a column. Let's say I wanted to do that for the entire first row. So I could just click and drag and go all the way to the bottom. But here I've done an example where there are a lot of data points. And it just keeps going, keeps going, keeps going, finally hit the end. So that works just fine. However, if I have more data, which we shouldn't get thousands of data points, but we might get hundreds. Let's say I just want to traverse the data quickly instead of clicking and dragging or scrolling all the way to the bottom. So here are some really quick shortcuts that I use all the time. So if I hold down the control key and hit one of the arrow keys, let's say I hit the down arrow key, it will bring me all the way to the end of the data. Now if I see I go one more down, it's an empty cell. And actually, let me type some numbers here so I can see sometimes we have two data tables separated by a space. So let's go back up to the top. If I go all the way, if I hit Control, hold Control and hit the down arrow key, it jumps to the end of the data table, but stopped at this gap. So if I hold Control and hit the down arrow key here, it jumps the gap to the start of the next data table. And then if I still hold Control and hit down again, it will just go down to the end of that data table. And let's look at this. Holding Control, I can hit right, we'll go to the edge, left, right, up, and the whole time here I'm holding Control. If I hit up again, it just skips the gap. If I hit up again, it goes all the way back to the top of the data table. So I use this one a ton. This just helps me traverse really big data tables. Okay, now let's say I want to highlight. If I just hold the Shift button while I hit arrow keys, it will just start highlighting over a row or over a column or down a row, up a row. That one I don't use so much because usually I just click and drag. But if I want to highlight this entire row or this entire column, and it's a really, really long column, if I combine those two shortcuts, hold Control and hold Shift, and then hit the down arrow key, it highlights all the way down the whole row. Now, this works the same. Hold Control and Shift, hit the right arrow key, it does the row. Now, if I hold Control and Shift and then hit down and then right, it highlights this entire column and then all the way over to the end of this data. And I can, of course, do it to jump the gap again and highlight the other data table if I want to do that for some reason. Sometimes, this one is a little less important. Let's say I'm already at the bottom of the data table. If I want to highlight it, Control Shift, I'm going to hit left and up, but I don't want to include that last or the first row. If I just hit Shift, or if I let go of Control, but I keep my finger on Shift, I can alter the end rows. So I can just, Control Shift up to highlight everything, let go of Control, but keep Shift held down to get rid of that. Okay. Two more really quick ones that you actually might use. If I want to insert a row between these two, if I just highlight this whole column, so if I click on the column header, it will highlight the entire column. And I can right click now and I hit insert. It will just insert a row to the left of it. I can do, or insert a column to the left of it. And I can do the exact same things with rows. If I click this row 9 header, it will highlight the whole row, right click, insert, it will put a new row above it. Sometimes that will be extremely useful. Some people may never use it at all. And similarly, I can highlight, right click, delete, and I'll just get rid of it all. Highlight, right click, delete, gets rid of it. And I lied, one more useful thing, more of a formatting issue. let's say I'm giving a really long column header, and then here's a second header. So because it's really long, it just stops showing it. I can drag to make it visible, but we don't always know how big that will be, and as you can see, sometimes it lags and it won't actually show you. But if I move my cursor so that it is on the boundary between these two columns, my cursor will change from this plus into this thing. It's a vertical bar with an arrow pointing in either direction. If I double click, it will automatically size to the largest thing in that column. Okay, so that's it for shortcuts, and I believe this is probably it for the videos unless I find a need later on. Good luck with all of your labs.